craft of shaping and forming metal is one of the oldest skills in the world, and long before the Industrial Revolution, it was known that many metals are easier to work when they're hot. The ring of the blacksmith's hammer was a part of rural life for centuries. An expertise handed down from father to son, from generation to generation. But today, manufacturing design teams have much more versatile and exciting techniques to play with. They can shape metal by machining, but this is expensive. It needs skilled men to do it, and not all materials can be machined easily. Metal can also be formed by casting, but you need metal which can be melted fairly easily so that it'll flow freely into the cavities of a mold. But again, there are drawbacks. Some stainless steels have a poor fluidity, and even when the metal used is fairly fluid, the finished article may not have enough tensile strength and toughness to do its job properly. Forging, on the other hand, is an excellent method of inducing both strength and toughness into metal. Here you take the hot solid metal and shape it using a large force controlled with great precision. Forging in this way develops the maximum impact strength and fatigue resistance. An important, indeed vital consideration in these days when metals are expected to perform at high speed and under great pressure. Put simply, forging is the process of forming metal into a specified shape by applying an external force. In this village forge, the heated metal is placed under a hammer, and the final shape of the forging is determined by the tools pressed onto the metal by the weight of the hammer. They're what's known as swaging tools. This is an ideal way of making small one-off articles. But what about a ship's propeller shaft, for instance? Exactly the same principles of forging apply, but on a vast scale, and the operation is a slow and delicate one. This technique is known as hot press forging. It begins with an ingot of metal, which can weigh anything up to 70 tons. The process will not only change the shape of the ingot, but also its internal formation. When working an ingot of this size, it's important to get it to the correct forging temperature steadily and slowly. Too rapid heating would cause steep temperature gradients, which could set up thermal stresses and quite possibly crack the metal. In this particular case, the ingot was preheated to 650 degrees centigrade for 12 hours, and then held at this temperature for another 8 hours. It was then raised to 1250 degrees and held there for a further 12 hours. As the temperature mounted, the metal relaxed, as it were, and the internal stresses were reduced. When the ingot has reached the correct temperature, it's moved to the forging press. The 4,000-ton press requires considerable skill, experience, and teamwork to operate. Although the job demands great precision, speed is essential. From the moment the ingot leaves the furnace, it starts to cool, and it'll only remain in a workable condition for a couple of hours. Trying to prolong this time isn't possible. Raising the temperature higher would result in oxidation and a coarse grain structure. The ingot would lose its malleability.